A piece of wire 45.2 centimeter long has a current of 12 amp. The wire moves through the uniform magnetic field with the strength of 0.3 Tesla. Calculate the magnitude of the magnetic force on the wire when the angle between magnetic force and the wire is 0, 45 degrees and 90 degrees. So we need to calculate the magnetic force in 3 different conditions. So let's start with part A. In order to find magnetic force, we need to use this formula. F equals to B, which is magnetic field strength, times I, which is the electric current in terms of amp, L, which is the length of the wire, and then sine theta. Theta is the angle between B, which is the magnetic direction, and the direction of I, or direction of wire, which is going to be the same thing. So we have F equals to 0.3, I is 12, L is 45.2 divided by 100, because it is in terms of centimeter, we need to convert it to meters, sine 0. Since we have sine 0, the answer is going to be 0, because sine 0 is 0. Let's do the second part. Second part is going to be the same thing. In this case, the angle between wire or current and the magnetic field direction is 45 degrees. So this is going to be F equals to 0.3, 12, 45.2 divided by 100 sine 45. So that will be 1.2 Newton. And part C is when the angle between them is 90 degrees. So F equals to 0.3, 12, 45.2 divided by 100 times sine 90. Sine 90 is 1. So when you calculate it, it's going to give you 1.6 Newton. So we have 3 different magnetic force depending on the theta. As you see here, if they are perpendicular, if the wire and magnetic field are perpendicular, we have maximum magnetic force. However, if they are parallel, means that the angle between magnetic field and wires, if the theta is 0, it means that there is no magnetic force. So it is increasing from 0 to 90 degrees. So this is the minimum value of magnetic force. This is going to be the maximum value of the magnetic force.